Okay, this is a quick tutorial on using a state machine, actually a quick example on using a state machine in Labview. So if I'm going to, a state machine is a software architecture or a design pattern that allows us to organize our thoughts and break problems down into smaller, more digestible pieces. A state machine can be generated using a state diagram. So here's a state diagram I threw together. What we're going to do is we're going to create a program that will do some initialization. I don't have any hardware hooked up to this machine, but we could init some analog output or some communication or something to spin the motor, some input resources to read some stuff. We'll have an index pulse, and we'll wait for that pulse. And if we get the pulse, we'll transition to a state called waiting for button. If we get that button pressed, we'll spin the motor, and then we can head on back. There's also a shutdown state that's accessible from the waiting for index pulse case. So, so the way that I'm going to do this is I'm going to create a state variable that's going to be an enum, and I'll have my 5 states, which are the 5 circles that are here. And then I will program the code in each one of those states to do whatever that state happens to need. And then I will manage the transitions. So a state machine is defined by some number of states and the transitions between the states. And the nice thing is that for a given state, I only have to worry about the transition or the code that state needs and the transitions in and out of that state. So for example, the index pulse state won't have to worry about anything regarding the button, which is nice because sometimes when we get different parts of our code confused, then we can make problems harder than they need to be. So I'll need to start things off. I'm going to have my state variable. I've got Labview open here, but I'll minimize this guy so that I can see my state machine here. And so to start things off, I'm going to grab an enum, and we're going to call him state. And then rather than going in and directly editing the items, what I'm going to do is I'm going to come in and I'll say, actually we'll go to right-click, Advanced, and Customize. And so I'll get a control here that's just this, and I'm going to change him from being a control to being a strict type def. The difference between type def and strict type def is pretty subtle, but what a type def is it allows me to have constants that relate back directly to this control. And so if I were to add a state later, then I could simply change it here, and all of my constants and variables would all update. And if I have, I could eventually have dozens or even hundreds of constants. And this could end up saving me some time when things change, because things will change. So I'm going to add my states. My state variable could also be a string. It could be anything, but enums are nice because they play very, very well with the case structures in Labview. So I've got a state init. I've got waiting for pulse, waiting for button, running motor, and shutdown. I don't have to be too careful with the language that I use here, because these will be encoded in an enum, so I'm not going to have to remember this exact language. So there's this guy, and then I can close him. He'll ask me if I want to replace. We'll say yes. I've got to save him. All right, so now I have this control. And so if I bring up, I can do this so I can see my state diagram while I'm working here. And so what we're going to do is, well, we're going to need a program that runs continuously here. So that sounds like a while loop. So I'll grab a while loop. And then my state variable, I'm just going to wire that into actually my state variable wants to be an indicator, so I'll change him to be an indicator just so I can see what's going on. And I'm going to create a shift register that's going to keep my state. And here's the first example. I'll right click and do create a constant. And I now have a constant of the type def, and I'll wire up an init. Scroll over here. And then I'll drop a case structure. and wire up the shift register to my selector. And I have two, init and waiting for pulse. And if I right click and do add a case for every value, well, now I have init waiting for pulse. So the things I need to do, so in init, right, we could so if I needed to set up some resources, configure analog inputs, analog outputs, I can do all of that here. And then I also need to decide what's going to be the next state. Well, if I refer to, oops, make a copy of. If I refer to my state diagram, from init we go immediately into waiting for index pulse. And so there's only one transition out of this state. The only way to get into it is the start. So that is where we'll start. And then I have one more thing that I need to do, which is the in fact, actually, I can just take care of the case structure here, which is to say that if the current state is if the state is equal to shutdown, then we will stop. And just to make my VI play nicely with, well, everything else, I'll make the delay pretty big here because this is just an example program, and so if I can sort of see some things running, if we end up having some counters or anything going in here. Alrighty, so then now all I need to do, right, I've got this structure set up, I've got my state variable, I'm displaying this to my front panel. So all I need to do now is just fill in every state. What does each state do, and then how do I manage the transitions out of that state? I don't have to worry about transitions into the state, right, because that's going to be taken care of by whatever state sent us there. So, so we've got nice now simple little problems, and I just need to look at each state and the arrows going out of that state on my my diagram, and so I can just come along here and say waiting for pulse. All right, so well, I don't actually have don't actually have any hardware hooked up here. So what I'll do is I will create a button, one called index pulse. I have another button called user button. That's going to be my button for the next case. I need motor timer. We'll make that be in milliseconds. And change his representation so he's like a U32. I think that's what the timers come out in. And then we've got we'll do an LED to say motor on. So now I've got my indicators here, and of course Labview has thrown these all over the place, so I'll have to go and find them all. If I can't find one, I can come to my front panel and double click, and it'll zoom in and tell me where these guys are. But there we go. So for the waiting for pulse, I'm going to need the index pulse. And so if the index pulse, again, if the index pulse is true, I'm going to move to the waiting for button case, and if it's not true, then I will move to, I will just stay here. So I could do that with a case structure, but this guy's also pretty nice to select, because then I can see, it's sort of nice for the code because I can see what's going on. So I'll control copy a couple of these down, and so if index pulse is true, we're going to go for waiting for button, and index pulse is false, I'm going to go to stay in waiting for pulse. And then the catch here is I want to make sure that my mechanical action is set so that these buttons unselect themselves. Otherwise, I'll have to use local variables to set them back. And so where would be the right place to set index pulse back to false? Well, it would actually be in the waiting for button state, in the next state around, because that's when that would that true value would happen. So again, waiting for pulse, waiting for button. All right, well, here's the user button. I'll drag that guy in. Again, grab select, wire him up. I'm going to hold down control to get some more copies. And you already see now, this is a very simple program, but I've already got over half a dozen copies of my constant that's attached to my enum. So I'm glad I've got that as a strict type def. So if things change at all, I need to add a state. I don't have to go recreate all these constants. It'd be a real pain. So again, user button here. If it's not pressed, we stay in waiting for button. So if false, stay in waiting for button. If true, we're going to go to run the motor. Okay.